Welcome back, everyone. So today's video is one that I'm personally very excited about because in my view this is the start of the final push in what has been an over 7-year saga of building this boat-tailed Speedster completely from scratch. And that starts here with the final teardown. You can see I've got a couple friends here who are in town visiting. They're helping me out with this. We're basically just tearing down the car completely, taking all the subsystems apart. We'll pull the engine, pull the transmission, and take off pretty much everything from the frame, really. And that'll set the stage for being ready to get into some of the final bodywork, polishing everything that needs to be polished, finish welding everything that's not fully welded yet, paint anything that needs to be painted, etc. And that was my original plan for this video, was to get into that final welding and final bodywork. But I kind of got distracted with something that has been in my mind for the past 6 years of this build, really. Since I put together the front suspension, I haven't actually been very happy with it. This car has something called hairpin radius rods in the front, which hold the axle to the frame. Those have been in practice pretty much as long as hot rodding has existed, so they're viewed as very traditional in quotation marks. But there's a problem with them when you're using them with a tube axle, like you can see here on my little subscale models I made. When you have those control links come back to a single point, it constrains the axle to only be able to move up and down relative to the frame. It can't tilt left and right, like if one wheel hits a bump or the other wheel goes over a pothole. An I-beam axle, on the other hand, is able to accommodate that twist because an I-beam is not stiff at all in torsion, whereas a tube is extremely stiff in torsion. So I made the decision, I'm going to be breaking from tradition. I'm going to convert to a 4-link suspension, which you can see here. It'll handle better, it'll go over bumps better, and it'll be safer. And so that's what I'm going to be doing in the rest of this video. But I'm not going to be making just any 4-link front suspension. There's a couple innovations that I'm going to make along the way that in the end are going to result in a 4-link suspension that, as far as I'm aware, is unique as far as hot rodding goes. Okay, so here is the layout that I've settled on after quite a bit of time of mocking up different concepts. You can see I've been 3D printing a lot of different prototypes for the batwing, which is the piece that gets welded to the front axle that serves as the front support for these links, as well as the support for the spring. And this is the batwing that's currently on there right now from the hairpins. And the main constraints I'm working within now is, one, obviously the extra volume that these rod ends take up compared to the hairpins, which just came in right here. And the clearance to the steering arm, as this moves forward, that sort of defines the limit of where I can put this lower mount. And also the steering arm travel up here. It gets very close right there. And also the spring shackle travel down here. So you can see I've had to change to an asymmetric setup for the batwings, where this lower mount gets extended down a little bit to give clearance for the spring shackles right there. And then the front one actually gets moved forward above the spring. That's so that back here my mount can clear the steering box, because I'm going to have my ball joint stud go all the way through the frame, have a nut on the back side. If that was just above here, then I don't really have room there between the steering box. So that'll still work totally fine as long as they're equal length and parallel. It doesn't matter if they're a little bit staggered like that. And I think it kind of looks a little bit cooler from the side profile. So this is an early Ford rod end off of a Model A, and it's pretty different in construction to modern ball joints, and even the ball joints that replaced these ones in the late 30s and 1940s. The way it works is you've got this pin here with the tapered shank and a spherical ball on the top. That's pretty standard. But inside of this housing, you have this spring here, which is inserted first. It has this little cup on there, which contours to the ball. And then the pin is inserted through this hole. And then on this side, you have a threaded plug that also has a similar concave contour there. That gets threaded in and preloads the ball against that spring. The point of the spring is to absorb shock and road vibration from your steering system so that it doesn't get translated directly back to your steering wheel. And that works great for that, but this will not work as a suspension control ball joint because the spring will have too much give in it. For suspension rods, you want them to be pretty stiff and you don't want extra give in it like this. So I want to use this model because it has that early look and style that I'm going for. I don't want to use a modern ball joint. So I'm going to modify these to remove the spring by adding just a steel spacer in there and remove these steel on steel ball joint cups and replace them with some custom polyurethane bushings, which is the same material that modern suspension joints use. So that should give me the performance that I'm looking for while retaining the 1920s look that these have. So I'm starting off here just by cleaning up these housings a little bit because I want to give them a nice finished and polished look. And I'm cutting off the port that would have the grease fitting on it too. And I'm gonna just weld that up and smooth it off because I won't have the steel on steel contact anymore, so I won't need that greasable fitting. But just with a combination of the angle grinder and then this right angle die grinder, I was able to get all of these nicely polished up and gave them a quick coat of WD-40 here too, just so they don't rust on me. These pieces here are those threaded plugs, and they are heat treated to a pretty high hardness, but what I want to do is machine off that concave feature that they have. So I need to anneal them just by heating them up red hot and let them cool, and after that metal will be a much lower hardness. I can put it in the lathe and just face that off real quick. So to make those new polyurethane cups I've been mentioning, I started out by 3D printing this mold here on my bamboo printer. I printed this out of the TPU filament that they have, which is a flexible rubbery filament that I chose because it would make it easier to pop these out of the mold after I've cast them. And this is my first time working with this castable polyurethane, but it's pretty straightforward. It's just a two-part mixture. You mix it up just like epoxy. I also added a little bit of black dye. The working time is pretty short, only a few minutes, but you can pour it into pretty much any mold that you have. And this is a really simple mold, but a lot of people will use this for casting much more complicated pieces too that it works really well for. This first attempt didn't work at all because I didn't put any mold release on the mold, so the urethane just completely stuck to it. So for the next try, I printed another mold and spread some of this wax on it, and that worked really well. I was able to just pop them out one by one after it. And I chose the polyurethane here that had a 90A durometer, and I think it was a pretty good hardness. I could recast them in a little bit of a harder durometer in the future if I really wanted to. Okay, so here's the components now of my re-engineered early forward ball joint. This is the steel plug that replaces the spring, so that piece slides in first. Next, I've got one of these polyurethane cups here that you saw me cast. Those will go in, well, one of those goes in next, and then just kind of put a little dab of grease on it. Because I don't have the steel on steel contact anymore with the ball, I should be good to just grease these once and then forget about it. You saw me also remove that grease plug because that's not really necessary anymore. Other urethane plug goes in, and then this threaded plug tightens that right up. And there we go. Really nice motion there, and under the suspension loads, the ball joint won't compress because there's no spring anymore, but still has that same look that I was going for. Another thing I think is important to go over here is these ball joint pins themselves and the concerns that I had with using them for suspension components as opposed to steering components. This one on the left is an original Ford ball joint. It's almost 100 years old now, but is actually in pretty good condition for that. These are very difficult to find, and when you do get them, they're usually very worn out. This is a modern reproduction. These are very available online. You can buy them for $10 to $20 each. And if I take a file to them, you can see this one, the file skates right off, doesn't bite in at all. Whereas this one, the file digs right in immediately. So I was concerned with using these for highly loaded suspension components because I don't know what alloy steel this is, and I pretty much have to assume it's the lowest grade mild steel possible. So I'm going to show you what I did to estimate the suspension loads that I'm going to see and calculate back the maximum stress that would be produced in this part to see if this was adequate or if I would have to come up with a different solution. The highest loads on the 4-link bars are going to be when the front wheels are locked up and sliding on dry pavement. And in that case, we'll have a normal force, which is the vehicle weight on that wheel. In my case, that equals the spring force because it's the only forces that I have in the vertical direction. We have our friction force because the wheel is sliding, and those are all going to be balanced out by the forces in the 4-link bars. And those are what I care about. So if we assume 700 pounds of weight on one of the front wheels, we know our normal force and spring force, and we can assume a coefficient of friction of 0.75 for dry pavement, which gives us our friction force. And by taking some measurements and summing up the forces and moments, we can estimate the loads that we're going to see in the upper and lower control rods. But what about the ball joint? So now we know the maximum force that it's going to see. That's going to be balanced out by a shear reaction as well as a moment reaction. The shear is not going to contribute much to the internal stress of that pin. The bending moment reaction is going to dominate that. So let's check the bending moment reaction at two places: the minimum diameter and also the maximum distance to the mounting plane. We'll start by taking the cross section of those two areas along with some of the known dimensions that we have. We can calculate the area moment of inertia of those cross sections as well as the internal bending reaction based on the distance from the force that's applied. And then we can use those to calculate the maximum stress that we're going to see due to that bending moment reaction at those two sections. Those are what we use to compare to the yield strength of a given material. Like I said, I don't know what this material is, so I have to assume it's pretty much the lowest strength mild steel possible, which it probably actually is. And then we can see what our margin of safeties are, and they're both negative. So that means that under this load, that ball joint will yield in those two locations. So it seems that I was right to be suspicious of these aftermarket ball joints. So what if we had new custom ball joints made out of a higher strength 4140 steel? That would give us positive margins at both of those two locations, and pretty good margins at that. I also checked the bearing forces between the tapered shank of the ball joint and the base material that it's mounted in, and found that the base material would actually slightly yield under that load. This is a little bit more detailed than I'm going to go into in this video, but it's called beam and socket analysis if you're curious. And I found that I could fix that problem by making the shank a little bit wider and a little bit longer as well. Since I already have to have ball joints made out of a new material, I figured I might as well make these few changes as well. So while I wait for those custom ball joints to arrive, I'll make the 4-bar links that are going to connect them. And I'm starting here with the threaded end pieces, and this is the first time I've actually cut threads on a lathe like this. And it was really cool to see the threading tool just cut perfect threads right down the line there. And you have to do it in multiple passes, of course. This is one of the left-handed threads that I had to make 4 of each. And to do right-handed threads is the same process, but you just start from the opposite side and move the threading tool towards the headstock of the lathe rather than away from it. So I'll make these, and I have some DOM tubing that I'm going to weld these into to create the finished links. now I have those new ball joints that I ordered, and you'll see that I also had the new batwings made as well, and those turned out really nicely. There's a little bit of post machining that you'll see me do for them, but that will be pretty much it. And then here's the new ball joint in comparison to the older one, and you can see the updates that I made to some of the dimensions. So to get ready to weld those new bat wings to the axle, I'll disassemble it from the rest of the suspension and the frame, get it all taken apart by itself, and then take it up to the table here. And what I'm doing right now is only cutting off half of the weld of these bat wings, because I'm going to use them to clamp the new ones to weld the new ones on, and then cut these old ones off the rest of the way. That's so that I'll be able to use them to locate the new ones. So it makes the alignment effort very easy, because now the new bat wings will be just as aligned as the old ones without having to do really any extra work for that. All right, so there's the front suspension now, back together. I think it looks really good. It went together very well too. I set all the links to the exact same length there, and I really didn't even have to go through and adjust it at all. The caster looks pretty good. You can see the front axle is leaned back about probably 6 degrees or so. Super easy to adjust that, obviously, by just, shortening or lengthening the top or bottom rods. The one thing that's left that I have to fix still is now the clearance from the steering arm here to this lower link mount there. You can see right now I have the wheels turned all the way to the right, and this does clear right now, but as I steer the wheels to the left, which I'll show you, this rod starts to move up and it clashes with this bottom mount here. Obviously I'm going to trim these studs down shorter, but that's still not going to solve the issue. So what I'm going to have to do is cut the steering arm and lengthen that a little bit more to get a little bit more clearance there. So after I finished welding up that extended steering arm, I was able to confirm that it had fixed the clearance issue I had previously. And so now I'm just welding up fully the batwing connection to the axle itself. I'm doing this in a root pass and then a wider pass over top of that. I had a really big chamfer where the batwing meets the axle, so I'll have really good weld penetration there. And now it's time to just start the very long and tedious process of blending out these welds and making a smooth transition between the two pieces. One of the tricks that I wanted to share here is putting these vice grips off the head of the right angle die grinder. Without those vice grips on there, it was pretty much impossible to use these carbide burrs on the steel because you didn't have enough support and they would always grab and chatter a whole bunch and you wouldn't be able to really carve into the metal. But with the extra support of those vice grips, it's a complete night and day difference, and I can really take nice smooth carving passes into the weld there. Another trick I wanted to share is one that's sort of been popularized by Jordan from Bennett's Customs, and that's when you're using these circular sanding discs and you're trying to blend up on a radius. If you actually cut the circle into a square, the tips of that square will bend up along there and give you a nice smooth joint. But I think I actually have an improvement to that, which is instead of cutting into a square, you can cut these little slits in it all along the edge. I'm making sure to have a very clear leading and trailing edge to the angle cuts that I make. And now you don't lose the extra material of the square, but the disc still retains that ability to bend up along that radius and give you a really nice finish. So before I go back and reassemble the whole suspension, I'm going to take this opportunity to correct another one of the mistakes that I made early on in this project. And that's in the design of these spring shackles here that support the front leaf spring. Some of you already know what the issue is with the design of these. There's a couple, but the main one is that I had very low clearance between the front edge of this and the axle, so I didn't really have room to put a nut on that side. And so the way I designed these was for this bolt, or these bolts, to slip in through this side and then they thread in directly to here. And so that means that the threads are actually taking all the bearing force of that joint, which you really never want to do. Threads should not be loaded like that. And another issue is that there's no locking feature of these bolts either, so they could just come loose and back out, which would be very bad. There's things I could do to lock that, but I'm just going to change this design entirely and remake all these components in a way that will be much more sound. These new spring shackles are going to be the perfect first project for the newest addition to my shop here, which is this late 80s, early 90s Herco 3-axis CNC mill. This machine was upgraded about 15 years ago with a modern computer, with a modern controller and servo motors, so you can actually send it G-code now, which is what I'm doing here. This is my first time programming and running a CNC part, so there's definitely going to be a learning curve to this. But it's really just mesmerizing to watch the machine cut things by itself, especially things that I've designed and programmed for it. And this is definitely going to open up the horizon of things I'm able to create here by myself, and you'll definitely be seeing more of this in future videos. Okay, well there's the first CNC part that I have designed and programmed and run. And that's really, really cool. This is a whole new world that this is going to open up for me in terms of just general fabrication. You can see obviously I made a second one down here. and it looks really good. The surface finish is super nice and smooth. Had a brand new end mill that I used for the cleanup pass, so that worked out well. And the next thing now is going to be to make the other half of these spring shackles. All right, so there it is now, all back together, and I am really pleased with how that looks. I think that having those early Ford tie rod mounts on there, as opposed to the newer style ball joints or even modern bushings, really brings the whole look back together. And that's the thing that I have not seen anyone else do, is use those early rod ends, probably for all the reasons that you saw me have to correct in this video. But I think that effort was worth it. Let me know if you think that brings back a little bit more of the traditional look to the whole system. The front batwings up here, you can see they're very nicely blended back into the axle there. I like the shiny look of everything too, so that's why I sprayed a little bit of WD-40 on it to keep it from rusting on me. But yeah, that's something that's been in the back of my mind, like I said, since I built the original suspension 6 years ago or something like that. But now I'll be able to have just a lot more confidence in the front suspension when I'm going over bumps, or if like I come into a driveway at an angle, it'll be able to articulate over those surfaces the way that it should, and will be a lot safer as well. So the next things for this is going to be finishing the bodywork. I'm going to go over all the weld seams, sand that down, polish up everything, and then focus on finishing all the welding for the chassis. A lot of the pieces, like for example for the subfloor, are just tack welded together right now. So there's a lot of welding that has to be done there. And then we're going to get to paint. So let me know you got to the end of the video by telling me what color you think that I should paint the frame. The body is going to stay polished aluminum. there's never any chance that I was going to paint that. But the frame and steel components will be painted. So let me know, and thanks for watching, and I'll see you next time.